Okay, let's kick off this explainer. You know that feeling when you first spin up an AI coding agent? Those first 20 minutes are pure magic. But then you hit the wall, the dreaded hour one drop off. Seriously, if you've ever felt like your agent suddenly starts hallucinating or forgetting the most basic project rules, or just endlessly rereading the exact same files, yeah, you are definitely not alone. It's a common, incredibly frustrating struggle because it completely shatters that flow state we're all trying to lock into. You brought this AI on board to speed you up, but by mid-afternoon, it feels like you're literally babysitting it. Well, the core culprits here are context exhaustion and a total lack of cross-session memory. Basically, your agent practically starts from zero every single time. It's like, imagine hiring a brilliant junior developer, but every single morning you have to completely re-explain your entire tech stack, all your coding standards, and every decision you made yesterday. It's exhausting. And that's exactly what's happening under the hood when we spin up a fresh agent session. So here's what we're looking at today. First, the AI agent amnesia problem. Second, the everything-claude-code framework, which is an incredible performance optimization framework for Claude Code and other agent harnesses. Then we'll look at optimizing MCPs and context, solving that cross-session memory issue, setting up security guards and ECC tools, and finally, upgrading your whole AI harness. Let's get right into it. All right, Section 1, the AI agent amnesia problem. This is the hidden drain on your agent's brain power. Think of your AI's context window exactly like your computer's RAM. If you start throwing heavy model context protocol or MCP servers at it, it just absolutely devours your memory. You're taking your massive 200K usable space and shrinking it down to a suffocating 70K. Every single time you enable an MCP, its tool descriptions eat up tokens right off the top. So that remaining 70K, that has to hold your system prompts, the actual code you're trying to edit, and the AI's internal reasoning process. Honestly, no wonder it starts dropping facts. There's just no room left. Moving to Section 2, the everything-claude-code framework. Think of this as the ultimate task manager for your AI. Now look at the sheer scale of trust we're talking about here. Over 182,000 GitHub stars. ECC is an Anthropic hackathon-winning system with thousands of forks. It has been battle-tested over 10 months of intense daily production use by a huge developer community. So this isn't just an experiment, it's a heavily vetted solution. And it is way more than just a simple config file. It is a full-blown performance optimization system. We're talking skills, memory, security scanning, and super smart MCP configurations all packed into one open source repo. Instead of reinventing the wheel for every single project, ECC hands you a structured directory of event-driven hooks, basically scripts that fire off during lifecycle events, along with pre-built commands and sub-agent definitions to actually parallelize your workflow. Which brings us to Section 3, optimizing MCPs and context. It is time to stop reinventing the wheel with heavy servers. This is where ECC really shines. It swaps out those all-or-nothing heavy MCPs for selective, super lightweight CLI-backed skills. And the best part? They cost literally zero token bloat. Think about it. If a platform already has a robust command line interface, spinning up a heavy MCP server just to interact with it is, well, it's just wasteful. As the source material points out, instead of keeping something like the GitHub MCP permanently loaded, you can just create slash commands that call the CLI directly. You're wrapping existing tools, like the GitHub or Supabase CLI, into simple commands like /GHPR or /dbmigrate. The tool acts just like an MCP capability, but you don't completely wreck your context budget just by having it sit there on standby all day. And the payoff here is massive efficiency. When you combine this trick with ECC's model routing, like, say, dropping down to the much cheaper Sonnet model for 80% of your routine tasks and saving Opus only for deep architectural reasoning, you can slash your hidden token costs by around 60%. 60%! It makes your agent dramatically faster, significantly cheaper, and just incredibly laser-focused. Okay, Section 4, solving cross-session memory. Let's talk about curing that hour one amnesia. ECC has a brilliantly simple way of demystifying memory. It turns it into a totally practical workflow. You run a summary skill at the end of your session, save that state to a dated.tmp file, and then just pass that file as context when you start your next session. It's this elegant file-based workaround. A post-session hook captures exactly what you built, the decisions you made, and what's still pending, and saves it. Next morning, you load it in, and boom, your institutional knowledge is totally preserved. Moving on to Section 5, Security Guards and ECC Tools, because we need to bring some serious enterprise guardrails to these AI agents. Look, giving AI external tool access requires a rock-solid security posture. ECC integrates something called Agent Shield to automatically scan for vulnerabilities, secret leaks, and misconfigurations across your entire setup. It's running over 100 static analysis rules in the background. It checks everything from hard-coded API keys to hook injection risks. It even uses a multi-agent pipeline to red team and blue team your own configuration before you deploy it. That's next-level protection. And to roll all this out safely, there's the hosted ECC Tools GitHub app. It actually analyzes your repo's history and opens selective pull requests to recommend only the components you genuinely need. There's a free open source tier that is perfect for public repos, giving you basic PR checks and 10 runs a month. And then there's a pro tier for $19 a seat per month, which unlocks unlimited repo analysis and deep PR audits for private teams. Finally, Section 6, upgrading your AI harness. Let's talk about why this matters no matter what tools you're currently using. Check out how incredibly versatile this is. ECC works natively across Claude Code, Cursor, OpenCode, Codex, Gemini, and GitHub Copilot. It is a fundamental agent harness performance system. It standardizes your entire team's workflow. So you could have someone coding in Cursor collaborating perfectly with a developer using the Codex CLI, and they are both adhering to the exact same AI standards and memory patterns because of that shared repository of hooks and skills. And this is all tied together by their new Hermes operator layer. This acts as the cross-harness glue, and it really proves a much bigger point. We have to start treating AI agents like actual systems that require deliberate optimization. Just like you'd optimize a database or a front-end bundle, you have to optimize your AI context. The Hermes layer makes sure your custom skills and security rules are totally portable, no matter where the AI is running. So I'll leave you with this question to chew on. Are you ready to stop reinventing your AI agent's workflow by optimizing your memory, shrinking that massive MCP bloat, and locking down your security? Are you going to keep treating your AI like a forgetful intern? Or are you ready to actually upgrade your AI harness? The everything-claude-code framework gives you the exact blueprint to move past the novelty phase and into robust, production-ready AI development. Thanks so much for joining me on this explainer today. I really hope this helps you reclaim your context window and get the absolute most out of your coding agents.